Hello and welcome to Built and Deployed, a technical video series for cloud architects. My name is Bill Wimsatt. I'm a cloud director at Oracle's cloud engineering organization. And in a previous episode of Built and Deployed, we talked with Mohammed Goodarzi about capturing and processing IoT data for the University of Melbourne's Fogbus 2 research platform. We're going to talk with Kifan Deng, who's part of the team that built this platform and has been a researcher on that team previously, about the machine learning, and really dive into how he's using autonomous Oracle machine learning with different aspects of the Fogbus 2 architecture. So the data that you're storing in autonomous data warehouse, you're using certainly a lot of metadata about the different devices and about the infrastructure itself, because that's part of the research that you're doing. Are you storing any other type of data in that autonomous data warehouse?
Metadata between the devices, like the bandwidth, data rate, and the utilization, and the hardware, RAM and CPU frequencies. Such kind of information is enough for us to analyze the system performance.
Okay. Are you using any particular types of data structures for underneath that autonomous data warehouse? Are you using star schemas? Is it a big flat table? Do you happen to use some kind of normalized structure, 3NF? Tell me a little bit about the data structure that you have underneath autonomous.
As I discussed, the flat tables are very enough for us to analyze it. We only need the timestamp, at least at this moment, what is this device's utilization, CPU utilization, and RAM utilization, what is the bandwidth from device A to device B, and what is the package size is sending from device A to device B from device C to device B as well. So we need this information. We can run some analyze, and we can run some machine learning algorithm on that to get what we want.
Obviously, see machine learning on there. I think it's a big piece you and I are going to have a chance to talk about here. So tell me a little bit about how you're using Oracle machine learning on for the research platform.
Yes, so for Oracle machine learning, first of all, with that, we can access our data in ADB very easily. So we don't have to build a separate backend service to gather all the data and visualize it with a carefully designed front-end interface. With a few clicks and lines of code, we can then visualize the profile data of the Fogbus 2 system. It saves us weeks from repeated developments, and we use that to analyze how to improve or say scheduling mechanism. Or scheduling mechanism use some evaluationary algorithm, but we also want to try different kind of machine learning algorithm to see how the machine learning algorithm performs. So to do that research, we synchronize the data from ADB in OML and run some simple machine learning algorithm like decision trees, SVM upon it to see whether it performs better than our embedded scheduling mechanisms.
You certainly could have built your own machine learning platform. A lot of people do this. Something that we see very often is Pickle, PyTorch, Flask is kind of a typical Python, and I know the platform is written primarily in Python. What drove your decision to use OML versus using that kind of pattern? So OML on autonomous data warehouse versus that build it your own kind of approach?
Yes, there are actually two main reasons. The first reason is that the security. If we use OML, we don't have to worry about the security. We can just use the identity and access management from Oracle. And the second reason is that using OML saving our time, because if we do the repeating developments, we need to develop like a notebook kind of stuff to synchronize the data from ADB. We need to worry about how to synchronize the ADB data in Python code. To use OML, we don't have to worry about this. So it really saves us weeks from repeating developments and give us more time for research, allowing us to try out more ideas. This is very important. In this way, we use OML in Fogbus 2, not only for visualization and analyze, and also for machine learning and research, which helped us implement our framework design. Yes.
You mentioned a couple of the algorithms that you're using, decision trees specifically. Tell me a little bit about libraries and maybe some of the tools that you're using within Oracle machine learning.
So in OML, we used some traditional libraries like NumPy, Pandas, such kind of libraries, and we also use OML. It's the built-in library, and we have many like SVM, decision tree, and the other libraries we can use. It really helps us to do the analysis and research.
For you, using this platform, where would you want to go? So you've got this framework, it's been up and running. What would be the future of how you would use OCI?
We plan to integrate the Kubernetes in the Focus to enrich the scalability and automating ability. And we also found that OCI container engine can manage the containers on the cloud tier. So with that, I think OCI can help us again decrease the development time and save us more time from research on the cloud tier.
Kifang, thank you so much for your time today. This is a really exciting platform. I've really enjoyed talking with you about how you're using autonomous and machine learning. So thanks again. This has been Built Deployed. Thank you so much for joining us, and stay tuned for more technical conversations with other OCI customers.